December 18, 1944. The Ardennes forest, near Malmedy, Belgium. The fog hung so thick that morning it seemed to have substance, a grey wall that pressed against the frozen earth and muffled every sound. Lieutenant Colonel Heinrich Schreiber of the 12th SS Panzer Division stood at the edge of what had once been a road and studied the terrain before him with growing satisfaction. Behind him, 43 tons of German steel sat idle, his Panther tank and 19 others, their engines silent, their crews waiting for orders that would not come for hours yet. The road, such as it was, had ceased to exist. American bombers had cratered it 3 days prior, then retreating American engineers had finished the job with demolition charges that left gaps 20 feet wide and 12 feet deep. Beyond the cratered road lay a ravine, its wooden bridge reduced to charred timber floating in ice-choked water. Beyond the ravine rose a slope of 42 degrees surfaced with mud that had frozen into ridges sharp enough to shred tank treads. And beyond all of this, somewhere in the fog, lay the town of Malmedy and the road junction that represented the fastest route to the Meuse River and the ultimate objective of the entire German offensive. Schreiber had studied the American withdrawal for 2 days now, watching their deliberate destruction of every road, every bridge, every viable path that German armor might use to advance westward. The Americans were retreating in confusion, their units scattered and disorganized by the surprise German assault that had shattered the quiet sector on December 16. But even in retreat they were methodical, using their engineering units to make the landscape itself into an obstacle. Schreiber respected the professionalism even as it frustrated him. His orders were to reach the Meuse within 48 hours. He had now been stationary for 36, unable to advance because the road no longer existed and his tanks could not cross the ravine or climb the slope beyond. German engineers were working to construct a temporary bridge, but their equipment had been delayed by fuel shortages and the work would take another full day at minimum. He checked his watch, 0642 hours. American artillery had been quiet since dawn, which was unusual. The fog would lift soon, and then German air support might be able to locate and suppress the American guns that had been harassing his position throughout the night. Once the bridge was complete, once his panzers could move again, the advance would resume. The Americans could destroy roads, but they could not destroy them all. Eventually the German armor would break through, would exploit the gaps in the American line, would reach the Meuse and split the Allied armies just as the plan required. It was simply a matter of time and engineering, and the Wehrmacht had always excelled at battlefield engineering. What Lieutenant Colonel Schreiber did not know, what he could not see through the fog that concealed the American positions 1,000 yards to the west, was that at that precise moment, at 0642 hours on December 18, 1944, 300 American combat engineers were completing work on a road that should not have existed. They had built it in 11 hours and 17 minutes. Working through the night without lights, constructing a path across terrain the Germans had deemed impassable, using techniques and equipment and a philosophy of engineering that would render obsolete every calculation the Wehrmacht had made about how long the Ardennes road network could delay the American response. The Battle of the Bulge had entered its 3rd day, and the German offensive was already behind schedule. Adolf Hitler's plan had depended on speed, the ability to thrust armored columns through the Ardennes, capture critical road junctions and fuel depots, reach the Meuse River within 72 hours, and then drive on to Antwerp before the Allies could respond effectively. The entire operation rested on a series of assumptions about timing, about how quickly German armor could move through the Belgian countryside, about how long it would take the Americans to organize an effective counterattack. The planners in Berlin had studied the terrain exhaustively, had calculated road capacity and bridge load limits, had estimated how long American defenders could hold each critical junction before being overrun. But they had made one fundamental miscalculation. They had assessed American engineering capability based on German standards, assuming that American combat engineers would operate with roughly the same speed and effectiveness as their Wehrmacht counterparts. They had analyzed the Ardennes road network and concluded that once key routes were destroyed, it would take days for the Americans to restore mobility. They knew the Americans had engineering units, every modern army did, but they assumed those units would be constrained by the same limitations that governed German engineering, limited equipment, limited materials, limited ability to improvise under combat conditions. They were catastrophically wrong. The American combat engineer in 1944 was not simply a soldier with technical training. He was the product of a society that had spent a decade building the Tennessee Valley Authority, the Hoover Dam, the Golden Gate Bridge, thousands of miles of highways and airports and power grids, all on schedules that European engineers considered impossible and budgets that seemed limitless. The American engineer came from a culture that viewed obstacles not as permanent features to be worked around but as temporary problems to be solved through application of machinery, material, and aggressive optimism. He had trained on equipment that didn't exist in comparable quantities anywhere else in the world: bulldozers and graders and power saws and portable welding units and pneumatic tools, all manufactured by American industry at a scale that defied comprehension. And now these engineers were in the Ardennes, and they were very angry. The 291st Engineer Combat Battalion had been stationed near Malmedy when the German offensive began. They were not frontline combat troops. Their mission was infrastructure support, building bridges and maintaining roads for the supply columns that fed the American advance into Germany. Most of them were in their early 20s, draftees from places like Kansas and Ohio and Oregon, young men who had worked construction or farmed or gone to engineering school before the war. They were not supposed to be fighting tanks. They were supposed to be building things. Instead, for the past 48 hours, they had been destroying things, blowing bridges and cratering roads to slow the German advance, then retreating westward under artillery fire and sniper attacks. They had watched the 99th Infantry Division get overrun. They had seen American soldiers fleeing in confusion, abandoning equipment, speaking in stunned voices about German tanks appearing out of the fog at dawn. The engineers had mined roads and then covered the retreating infantry, using their rifles and machine guns because there was nobody else to do it, learning what combat actually felt like when the people shooting at you were trying to kill you specifically rather than just firing in your general direction. Now, on the morning of December 18th, they had been ordered to stop retreating. General Courtney Hodges, commander of the First Army, had issued a direct order: hold the road junction at Malmedy regardless of cost. The junction was critical. If the Germans captured it, they would have a direct route to Liège and the bridges across the Meuse. If the Americans could hold it, the entire German northern thrust would be funneled into narrow roads where they could be engaged by American artillery and air power. The 291st Engineer Combat Battalion, along with remnants of several infantry units that had been shattered in the initial German assault, were all that stood between the 12th SS Panzer Division and the road junction. Major Robert Yates, commanding the 291st, studied the situation with the methodical pessimism of a career engineer. His battalion had approximately 800 men fit for combat. They had rifles, machine guns, some bazookas, and their personal weapons. They had no tanks, no tank destroyers, no artillery support beyond radio contact with batteries positioned 5 miles to the rear. They were occupying a position that was indefensible by conventional military standards, a loose perimeter around the town, spread too thin to stop a determined assault, lacking the heavy weapons necessary to engage German armor effectively. But they had something else. They had 27 bulldozers, 11 road graders, 8 portable sawmills, 43 pneumatic jackhammers, 17 trucks loaded with Bailey Bridge components, 60,000 board feet of timber, and 300 men who knew how to use all of it. And Major Yates had spent the past 6 hours studying the terrain and developing a plan that conventional military thinking said was impossible. The Germans were stopped at the destroyed road 3 miles east of Malmedy, unable to bring their armor forward because the route was impassable. They were working to build a bridge across the ravine, but Yates's scouts reported the work was proceeding slowly, hampered by equipment delays and American artillery harassment. The Germans would need at least 18 hours to complete the bridge, probably longer. Which meant Yates had 18 hours to make irrelevant every calculation the Germans had made about how to reach Malmedy. His plan was simple in concept and insane in execution. Rather than defend the existing road junction, the obvious approach, the one the Germans expected, he would create an entirely new road. He would construct a route that bypassed the junction completely, that brought American reinforcements and supplies in from the southwest along an axis the Germans weren't watching, using terrain the Germans had assessed as impassable for military traffic. The new road would cross 3 miles of forested hillside, span 2 streams, climb a slope of 38 degrees, and connect existing American positions to a supply route the Germans didn't know existed. It would need to be wide enough for truck traffic and strong enough to support the weight of American tank destroyers. And it would need to be completed before the Germans finished their bridge and resumed their advance. The engineers would need to build this road in darkness, without proper lighting, under intermittent German artillery fire, in temperatures that had dropped to 18 degrees Fahrenheit, using materials they would have to source from the surrounding forests because there was no time to wait for supplies to arrive through normal channels. Major Yates called his company commanders together at 1900 hours on December 17th and explained the plan. When he finished, there was a long silence. Then Captain James Gamble, commanding B Company, said quietly, "Sir, the field manual says that type of road construction takes 48 to 72 hours under optimal conditions." Yates nodded. "The field manual assumes we have time. We have 11 hours. Get started." What followed over the next 11 hours and 17 minutes was a demonstration of engineering that would be studied in military academies for decades afterward, not because it was elegant or theoretically sophisticated but because it worked despite violating every principle of methodical construction. The American engineers attacked the problem with a combination of technical skill and brute force improvisation that would have horrified their instructors at Fort Belvoir. They didn't survey the route properly, no time. They didn't calculate load-bearing requirements with precision, no time. They didn't prepare detailed plans or coordinate with higher headquarters or follow procurement procedures. They just started building. B Company took the eastern section, the forested hillside that needed to be cleared of trees to create a roadbed. They used chainsaws and axes, working in teams of 4 men per tree, cutting the massive oaks and pines that had stood for a century and letting them fall directly across the slope to serve as foundation timbers. Behind the cutting teams came bulldozers, their blades modified with improvised steel teeth welded on by battalion mechanics, pushing stumps and undergrowth aside, carving a shelf into the hillside. The noise was tremendous, chainsaws screaming, bulldozers roaring, trees crashing down. But the German artillery positions were too far away to accurately target sounds in the darkness, and the engineers gambled that the noise would be dismissed as normal battlefield activity. A company handled the stream crossings. The 2 waterways were 15 and 22 feet wide respectively, too broad for simple log bridges, requiring actual engineering. The solution was improvised from Bailey Bridge components, modular steel sections designed to be assembled into temporary bridges. But rather than following the careful assembly procedures, the engineers simply welded sections together in rough approximations of proper bridges, using portable generators and arc welders, working so quickly that the welds were rough and imperfect but strong enough to hold. They sank the bridge sections directly onto log cribs placed in the stream beds, anchored with rocks and debris, then covered the steel with timber planking so trucks wouldn't slip on the metal. Each bridge took 2 hours to construct, about 1/5 the time the manual specified. C Company worked the slope, the 38-degree incline that vehicles would need to climb. The ground was frozen solid, which meant bulldozers couldn't cut into it effectively. The solution was to build upward rather than cut downward, to create a ramp using timber and gravel, constructing switchbacks that reduced the effective grade to something vehicles could manage. They harvested timber from the trees B Company had felled, using portable sawmills to cut them into planks right there in the forest, then laying the planks perpendicular to the road direction to create traction. Behind the planks they dumped gravel and rock harvested from a stream bed, creating a surface that would support heavy vehicles. The ramp rose 60 feet in elevation over a horizontal distance of 400 yards, a gradient that made truck drivers nervous but was technically passable. The work proceeded with controlled chaos. There were no lights. The engineers operated by moonlight and the occasional flash of artillery in the distance. Communication was by shouted orders and hand signals. Injuries were common: men hit by falling branches, crushed by rolling logs, cut by chainsaws that slipped. The battalion medics worked constantly, treating wounds by flashlight, sending serious cases back to the aid station, but keeping the lightly wounded in place because every hand was needed. 3 men were killed by German artillery, a random harassment fire mission that happened to land among a work party at 0330 hours, but the work continued without pause. The Germans never suspected. Their reconnaissance aircraft couldn't fly in the darkness, and their ground patrols were focused on the approaches to the existing road junction, the obvious routes that military logic said the Americans would defend. The possibility that the Americans were building an entirely new road 3 miles to the south, through terrain the Germans had assessed as impassable, simply didn't occur to German planning staff. Roads took days to build under combat conditions. This was known. This was understood. The Americans might reinforce the existing junction, might establish fallback positions, might call in artillery or air support. But they wouldn't create new infrastructure in the middle of a battle. That was impossible. At 0659 hours on December 18th, exactly 11 hours and 17 minutes after the work began, the first American truck drove the full length of the new road. Major Yates rode in the passenger seat, timing the journey, checking for weak points that might collapse under repeated traffic. The truck bounced and swayed alarmingly on the switchbacks, the driver white-knuckled on the wheel, but the road held. The bridges held. The ramps held. At 0707 hours, Yates radioed division headquarters with a message that made no sense to the officers receiving it. New supply route to Malmedy complete and operational. Can support continuous heavy traffic. Send reinforcements. Over the next 6 hours, the Impassable road carried 217 trucks loaded with ammunition, food, medical supplies, and infantry replacements. It brought forward 4 M10 tank destroyers that would prove critical in the defense of the town. It evacuated 300 wounded soldiers who would have died if they'd had to wait for the Germans to clear the existing roads. And it completely invalidated the German timetable for capturing Malmedy, because suddenly the Americans could reinforce and resupply a position the Germans had assumed would be isolated and starving. Lieutenant Colonel Schreiber learned about the road at 1430 hours when his scout patrols reported heavy American truck traffic moving into Malmedy from an unexpected direction. He didn't believe the initial reports. There was no road in that area, the terrain was impassable. He sent additional patrols to confirm. They returned with reports that made no tactical sense. The Americans had constructed a functional road through forested hillside, had bridged 2 streams, had built ramps up a slope that should have been impassable for wheeled vehicles. And they had done it overnight, during active combat operations, without the Germans noticing. Schreiber requisitioned aerial reconnaissance once the fog lifted. The photographs confirmed what the patrols reported. A road that hadn't existed 24 hours earlier now stretched 3 miles through terrain the German staff maps marked as impassable. The road was crude, obviously hastily constructed, but it was functional, and it was being used heavily. American supply trucks were flowing in an uninterrupted stream, and the defensive positions around Malmedy were visibly strengthening hour by hour. The photographs were forwarded to Corps headquarters, then to Army headquarters, then to Berlin, where staff officers examined them with growing confusion. The Wehrmacht had excellent combat engineers. They had built the Siegfried Line, had constructed bridges under fire in Russia, had demonstrated repeatedly their ability to solve engineering problems under combat conditions. But they couldn't have built what the Americans had built in the time available. The mathematics didn't work. The required equipment wasn't that portable. The necessary materials couldn't have been sourced that quickly. The whole thing was impossible, except that the photographs proved it had happened. What the German analysts didn't understand, what they couldn't comprehend from their perspective within a resource-constrained military struggling to maintain operations while short of fuel and equipment and replacement parts, was that the American engineers weren't operating under the same limitations. When B Company needed chainsaws, they had chainsaws, dozens of them, military-issue equipment that worked reliably because American factories had produced them in quantities that allowed for spares and replacements. When a company needed welding equipment, They had portable generators and arc welders that were standard battalion equipment, not specialized tools that required requisitions and approvals. When C Company needed timber, they didn't submit requests through supply channels. They just cut down trees and milled them on site using portable sawmills that the German army didn't have equivalent to. The American industrial base had given these engineers not just equipment but abundance. They could be wasteful, could use expedient solutions that consumed materials inefficiently, could weld together Bailey bridge sections in configurations the designers never intended, because there were more bridges and more steel and more welding rods in the supply pipeline. They could work all night because they had portable generators to power their tools, could move heavy timbers because they had bulldozers and trucks in quantities that seemed absurd by German standards. They could accept imperfect solutions, rough welds, uneven grades, bridges that met minimum standards rather than optimal specifications, because they had enough material abundance to build things that were merely good enough rather than having to make scarce resources serve through perfect engineering. But more than equipment and material, the American engineers possessed something the Germans found difficult to quantify: an institutional culture that valued speed and improvisation over perfect adherence to doctrine. The Wehrmacht engineering manual specified precise procedures for road construction, detailed specifications that ensured quality and durability. The American engineers knew those specifications and ignored them whenever necessary to accomplish the mission faster. The German approach was methodical: survey first, plan carefully, execute precisely, inspect thoroughly. The American approach was pragmatic: start immediately, solve problems as they arise, accept good enough if perfect takes too long, inspect by using the road and seeing if it collapses. This cultural difference reflected deeper societal values. The German military was the product of a society that valued order, hierarchy, precision, the subordination of individual initiative to collective discipline. German engineers were excellent when operating within established procedures and given adequate time and resources. They struggled when forced to improvise, when the situation demanded creative solutions that violated doctrine, when speed mattered more than perfection. The Wehrmacht had strict hierarchies. Junior officers didn't question senior decisions, enlisted men didn't suggest alternatives to established procedures, deviation from protocol required approval from higher command. The American military, despite its own hierarchical structure, operated differently. American junior officers were expected to show initiative, to solve problems independently, to interpret orders based on intent rather than literal instruction. American NCOs were trained to think tactically, to make decisions without waiting for officer approval. American enlisted men were encouraged to be skeptical, to question procedures that didn't make sense, to suggest better approaches. This drove German observers crazy. The American military seemed chaotic, undisciplined, lacking proper military bearing, but it made American units extraordinarily adaptable when circumstances changed rapidly. Major Yates had made the decision to build the road without requesting permission from division headquarters, without submitting plans for approval, without following procurement procedures or coordinating with adjacent units, or doing any of the things military doctrine said he should do. He had simply recognized a need, developed a solution, and implemented it immediately using the resources at hand. If the road had failed, if the bridges had collapsed, if the slopes had been too steep, if German artillery had caught his engineers in the open, he would have been relieved of command and possibly court-martialed. But it hadn't failed, and so instead he had demonstrated exactly the kind of initiative and tactical creativity that the American military rewarded. The bulldozer became the symbol of this engineering philosophy, appearing so frequently in German intelligence reports and prisoner interrogations that it took on almost mythical status. German soldiers spoke about American bulldozers the way medieval armies must have spoken about siege engines, as machines of almost supernatural capability that could reshape the battlefield itself. The Wehrmacht had bulldozers, of course, but not in comparable numbers and not deployed forward with combat units. German bulldozers stayed in the rear areas, used for constructing permanent fortifications and infrastructure. The idea of bringing bulldozers to the front lines, of using them during active combat operations, struck German commanders as wasteful and dangerous. But the Americans brought bulldozers everywhere. Combat engineer battalions had them as standard equipment. They used them to clear roads under fire, to create tank positions, to bury destroyed vehicles, to fill in craters, to clear fields of fire, to push aside obstacles. German defenders in fortified positions would report that American bulldozers operated within rifle range, protected by covering fire from tanks and infantry but continuing to work even when under direct small arms fire. The bulldozer operators, enlisted men, often barely out of their teens, would climb into their machines and drive directly toward German positions, blade down, scraping away obstacles and creating approach routes for American armor, displaying a kind of casual courage that German observers found both admirable and incomprehensible. The bulldozer represented American material abundance, made tangible. Each one required steel and engine components and hydraulics and track systems, all manufactured with precision, all consuming resources and industrial capacity. The fact that America could produce these machines in such quantities that they became standard combat equipment, that bulldozer operators became as common as riflemen, demonstrated an industrial capability that Germany simply couldn't match. The Wehrmacht was fighting with carefully husbanded resources, counting every artillery shell, rationing fuel, cannibalizing damaged vehicles for spare parts. The Americans were paving roads in the middle of battles. The Malmedy Road held for the duration of the Battle of the Bulge. German forces never captured the junction, never broke through to the Meuse along that axis. The 12th SS Panzer Division eventually withdrew eastward after losing 40% of its armor to American tank destroyers and artillery, the panzers that Schreiber had expected to reach the Meuse in 48 hours instead spending 2 weeks grinding forward a few miles before running out of fuel and ammunition. The entire German northern thrust stalled and then collapsed, not because of brilliant American tactics or superior combat effectiveness but because the Americans could move supplies and reinforcements through terrain the Germans had assumed would be impassable. The 291st Engineer Combat Battalion suffered 37 casualties during the battle, including the 3 men killed during the road construction. They received a Presidential Unit Citation for their defense of Malmedy. Major Yates received a Distinguished Service Cross. The road itself was abandoned after the battle. It had been built as an emergency expedient, not a permanent installation, and once the main routes were cleared there was no need to maintain it. Within weeks, the forests began reclaiming the scar, snow covering the improvised bridges, vegetation growing through the gravel roadbed. But the photographs of the road were distributed throughout the Wehrmacht intelligence network, studied by German commanders trying to understand how the battle had gone so wrong. The analysts noted the construction timeline, the techniques employed, the equipment visible in reconnaissance images. They wrote reports about American engineering capability that bordered on the incredulous. They recommended that future planning assume the Americans could accomplish in hours what German doctrine said required days, that terrain assessments should account for the possibility that the Americans would simply build roads where none existed, that obstacle belts needed to be wider and more thoroughly destroyed because the Americans would repair or bypass them with disturbing speed. Some German officers understood that the road represented something more significant than just engineering efficiency. They recognized that they were fighting an enemy with fundamentally different capabilities, an enemy that could apply industrial-scale solutions to tactical problems, an enemy whose society produced not just equipment but an entire system, material abundance, institutional flexibility, cultural innovation, that made their army qualitatively different from any force Germany had faced before. The Wehrmacht could still win individual battles through superior tactics and veteran experience. But they were losing the larger war because they couldn't compete with an enemy who could build roads overnight, who could afford to be wasteful, who could turn doctrine into suggestions rather than immutable law. The German soldiers who surrendered in the Ardennes, who were marched to POW camps in the rear areas and who saw the American logistics network firsthand, reported being stunned by the sheer quantity of everything. They saw supply dumps stretching for acres, containing more material than entire German divisions possessed. They saw truck convoys that ran continuously, 24 hours a day, moving supplies forward in quantities that seemed impossible. They saw engineer units reconstructing bridges faster than German demolition teams could destroy them. They saw a military that operated with margin for error, that could absorb losses and continue functioning, that treated individual vehicles and equipment as disposable because there were always more in the pipeline. And some of them, the thoughtful ones, the ones who had believed in the ideology that told them German discipline and Aryan will would overcome material disadvantage, began to understand that they had been lied to. The ideology claimed that democracy made societies weak, that free peoples lacked the unity and determination necessary for total war, that American abundance was a symptom of decadence rather than strength. But the evidence of their own eyes contradicted this. The Americans weren't weak or decadent. They were building roads through impossible terrain in impossible time, and they were doing it not through fanatical discipline but through individual initiative and institutional trust and material abundance that came from a free economy rather than state control. The bulldozer, photographed by German reconnaissance, its blade scarred and dented from 11 hours of brutal use, sitting idle beside the Malmedy Road at dawn on December 18th, that machine became a more powerful argument against fascist ideology than any propaganda broadcast or political speech. It was physical proof that the democratic societies could outproduce, outbuild, and outinnovate the totalitarian states. It demonstrated that individual freedom and economic liberty created capabilities that central planning and forced unity could not match. It showed that Americans would work all night in freezing temperatures not because they were compelled by ideology or threatened by commissars but because they had voluntarily committed to a cause they believed in and were supported by a system that gave them the tools to succeed. The war would continue for another 5 months. Germany would fight with increasing desperation, would deploy whatever resources remained, would sacrifice hundreds of thousands more soldiers in a defense that everyone except the Nazi leadership understood was hopeless. But the outcome had become inevitable, not because of any single battle but because of accumulated differences in capability and capacity and philosophy. The Americans and British and Soviets could absorb losses and continue fighting. The Germans could not. The Allies could improvise and adapt and build roads overnight when necessary. The Germans could not. The free societies had proven themselves more resilient, more innovative, and more deadly than the totalitarian state that had claimed superiority. The bulldozer tracks in the frozen mud, visible in the reconnaissance photographs, told this story more clearly than any after-action report or historical analysis. They showed where American engineers had worked through the night, had moved earth and timber and steel through sheer determination and mechanical capability, had created something from nothing in time frames that seemed impossible. Those tracks, pressed deep into Belgian soil, marked not just a road but a philosophical truth, that freedom unleashed human potential in ways that tyranny could only simulate, that abundance arose from voluntary cooperation rather than forced labor, that democratic societies at war possessed hidden strengths that ideology-driven states could neither predict nor counter. The snow eventually covered those tracks, just as it covered the trenches and shell craters and all the other scars of battle. The forest grew back. The streams flowed clear again. The hillside where 300 engineers built the Impassable road became quiet farmland, worked by Belgian families who knew nothing of what had happened there. But the truth remained. Embedded in the historical record, preserved in the photographs and reports and testimonies, that on one frozen night in December 1944, American engineers had proven that determined free people with good equipment and institutional trust could accomplish what totalitarian planning said was impossible. And in doing so had demonstrated a principle that would outlast the Third Reich and shape the remainder of the century, that democracy, for all its apparent chaos and inefficiency, possessed resources of will and capability that no dictatorship could match, and that the future belonged to societies that trusted their citizens rather than controlled them. Retry Claude can make mistakes. Please double-check responses.